In this lesson, we will develop and discuss the concept of improper integrals. What is an improper integrals? What is improper about certain integrals? What is the process of integration? Integration is a method of measuring the area enclosed by the graph of the function with the x-axis. Is that right? Now, an improper integral is particularly associated with a definite integral. For example, you want to find the integral of integral 0 to, say, e ln x dx. Now, what is improper about it? Let's draw the graph of this. Now, the graph of ln x will be something like this. Is that right? Now, is this function defined at x equal to 0? As x gets closer and closer to 0 from the right, the function value goes to negative infinity. So, if you want to find the area enclosed by the graph of this from 0 to e, it's sort of an improper exercise. It is not very proper. So this is an improper integral. How about integral 0 to infinity of e to the power of negative x? Now, how about the graph of e to the power of negative x? E to the power of negative x, the graph goes that way. So, if I want to measure the area enclosed by the graph of this function, from 0 to infinity, the graph never touches a point on the x-axis. So, how do we measure the area enclosed by the graph with the x-axis? It is an improper integral. So, an improper integral is actually an integral that has, say, infinity as one of the limits, or at one of the limits the function is undefined. For example, if I want integral 0 to 2 of square root 4 minus x squared, what is improper about this? Well, at x equal to 2, well, this is okay. Let me just rewrite it as 1 over square root 4 minus x squared. Well, at x equal to 2, the denominator becomes 0 and the function becomes undefined. So this is an improper integral. So you have several types of improper integrals. We're going to look at these kind of integrals and how to evaluate them. A method to evaluate such improper integrals, and that's what we will discuss today. So one form of an improper integral is a definite integral where both limits, one or both limits of the integration is infinite. Now, for example, integral 0 to infinity f of x dx is an improper integral. Integral negative infinity to 2 f of x dx is an improper integral. Integral negative infinity to positive infinity f of x dx is an improper integral. Well, now, will an improper integral yield a definite value? Well, some of them do. So, if an improper integral yields a definite value, then it is called a converging improper integral. That type of improper integrals will converge to a particular value. In other words, that improper integral has a definite value. But some others don't have a definite value, and such integrals are called diverging improper integrals. So improper integrals can be converging or diverging, and we will test some of these integrals for convergence or divergence. Now, how about this? We talked about this. integral 0 to e ln x dx, is that an improper integral? If so, why? Well, you notice that this function is not defined for x equal to 0. Alright, now in order to evaluate an improper integral, we are going to develop a method. Now, if f of x is continuous on the interval a to infinity, there's no break in the function, then integral a to infinity f of x dx can be written as limit b approaches infinity, integral a to b f of x dx. In other words, the limit infinity is replaced by a finite number b, and then we take that b and take the limit of that when b goes to infinity. Take the limit of the value of that integral when b goes to infinity. We know the skill of taking the limit of functions, so we will use that in here. Similarly, if f of x is continuous on the interval negative infinity to b, then integral negative infinity to b f of x dx will be limit a approaches infinity, integral a to b of f of x dx. In other words, we replace that negative infinity by a, and after evaluating the integral, we will take the limit of that when a goes to negative infinity. That's the method. Alright, another one. If f of x is continuous on negative infinity to positive infinity, then we've got to break the improper integral into two pieces. We would say this is the same as integral negative infinity to c f of x dx plus integral c to infinity f of x dx. That's not difficult to understand. We want to measure the area enclosed by the graph of this with the x-axis from negative infinity to positive infinity. So first we measure the area from negative infinity to c, and then we measure it from c to infinity and add them together. There is no problem in that. Now each of these is an improper integral, and we can evaluate that using limit forms like this. So how do we write this? This will be limit a approaches negative infinity, a to c of f of x dx, plus, how will this become a limit? Limit b approaches infinity, integral c to infinity, well, c to b, we have replaced that infinity by b, so it should read limit b approaches infinity, integral c to b f of x dx. So these are some of the methods that we'll employ in evaluating such improper integrals. Okay. Alright, now we had talked about this actually in the last class. What is limit x approaches infinity e to the power of negative x? We talked about that. Limit x approaches infinity e to the power of negative x. Remember, e to the power of negative x is 1 over e to the power of x. And 1 over e to the power of x when x goes to infinity is 1 over e to the power of infinity, which is 0. So this limit is 0. There you go. Which is the same as limit 1 over e to the power of positive x, and that will be 0 when x goes to infinity. The value of that will be 0. Alright, let's now find the value of an improper integral. Now, why is this improper? You can see one of the limits is infinity. Integral 0 to infinity e to the power of negative x dx. In other words, what is the area enclosed by the graph of e to the power of negative x with the x-axis from 0 to infinity? Alright, you know how to find that integral, is that right? First of all, we will write this as a limit. What will that look like? integral 0 to infinity e to the negative x dx will be limit b goes to infinity, integral 0 to b of e to the negative x dx. And you know what integral of e to the negative x dx is. What is it? It is negative e to the power of negative x. That's right. Integral of e to the power of negative x dx is negative e to the power of negative x. And the limit is from 0 to b. And we take the limit of this quantity as b approaches infinity. Alright, let's apply the upper limit minus the lower limit. So this will be limit b approaches infinity, negative e to the power of negative b minus the lower limit is negative e to the power of 0. Alright, now what is limit b goes to infinity e to the power of negative b? E to the power of negative b as b goes to infinity is 0. So this value is 0. So we will end up with negative, negative, positive. E to the power of 0 is 1. So that will be limit b approaches infinity, negative e to the power of negative b plus 1. And you know this already. Limit b approaches infinity, e to the power of negative b is 0. So the value of this will be 0 plus 1. That's equal to 1. The value of this improper integral is 1. Is this a converging improper integral or a diverging improper integral? Well, it is a converging improper integral. That area converges to 1. Alright, another one. Evaluate the improper integral